So we're going to talk about the density lab. And in the density lab, what you are going to do is you're going to get some practice with how to work the balance, and you're also going to see some applications of learning about density. So if you think back to where we've talked about this in class, we know that density is equal to mass over volume, or we can abbreviate that as D equals M over V. So in order to complete this lab, you're going to have to understand how to work the balance. So what I have on the screen here is a picture of one of the balances that we have in the lab. So we have a couple that look like this one, and then we have a couple more on the other side of the lab. One of them doesn't always work, but the other one is very similar. It just looks a little bit different where the buttons are. So the first thing you'll want to do is make sure that the balance is on, and if it's not, you can press the power button right here. If you don't see anything on the screen, it's blank, then that means that the balance is probably not on. So before you put anything on the balance, you want to make sure that the balance that it is reading, the mass that is reading, is 0. So you can see here in the picture we have 0.0000 grams. If it does not say that, or before you start using it, you want to press this yellow 0 button. Sometimes the balances will also say tare. So you will see the term 0 or the term tare on the balance. So you're going to press that, and then you're going to open this door on the side here. So there's a little latch on the side, and you're just going to slide it open. It just slides back and forth easily and gently. You want to be careful with it. These balances are expensive and we don't want to break them. And then you're going to lay your penny directly on the balance. Now this is the only time this semester you will be able to lay anything directly on the balance. If you're weighing out a solid, or especially a liquid, you want to put it in something. So sometimes we will have little plastic weigh boats, or you might use a beaker or something of that nature. So you want to make sure that you're putting whatever you're weighing in something. Now for the penny, it's fine to just lay it directly on this pan here. And then the balance will give you a mass. So you're going to weigh your first penny, then you're going to take that off. You're going to zero the balance again by pressing this yellow 0 button. You're going to weigh your second penny, and then you're going to take that one off, press the 0 button, and then you're going to weigh the 2 pennies together. So that will get you the data for the first part of your lab. And if you ever have any questions, or you're not sure how to work something, always ask me or your lab partner, or if your lab partner is not sure, come ask me. Do not try to do anything with the balance or mess around with it if you're not sure what you're doing, because these are not cheap pieces of equipment to work. So if you look at the report sheet for your density lab, which is on Canvas for you, and it's a PDF file, in part A, you'll need to record the mass of each of your coins, and then you're going to add together the mass of the 2 coins and record the mass of coins 1 and 2 right here in this blank. So that's part A. Let's talk about what you're going to do in part B. So in part B, you're going to get a 50 milliliter Erlenmeyer flask out of your drawer. And the Erlenmeyer flasks are the ones that are shaped kind of like that. Okay, I'm a chemist, not an artist, so I know my drawings aren't great, but this is what you're looking for. The stopper you're going to need is the one that's labeled 1. So I'll show you in lab where the stoppers are, but you're going to get one of those that fits down into the 50 milliliter flask. So you're going to record the mass of your empty flask plus your stopper, And you want to wipe the outside of your flask out with a paper towel before you weigh it and hold it by the lip of the flask. You want to make sure you have a good grip on it, but you want to just hold it by the top and try not to get too much of your fingerprints on there, because the oil from your fingerprints will also affect the mass. And you don't want to be weighing the oil from your fingerprints. So once you have the mass of your empty flask and your stopper, then what you're going to do is you're going to weigh the empty flask plus your stopper plus your water. So you're going to fill your flask to overflowing with distilled water, and then you're going to put the lid in it, and you're going to wipe off the outside. Make sure that the outside of your flask is dry before you weigh it. And once you do that, then you're going to record that mass. Then what you're going to do is you're going to dump out the water, and you're going to obtain an unknown liquid from the lab bench. So you won't know what the identity of the liquid is, but you don't need that. You just need to know what the mass is. So you're going to again fill your flask to overflowing with your unknown liquid, put the stopper in, wipe it off, and weigh it. And you're going to record that mass. So once you have that data, what you're going to do, and I'm going to label these here so that we can use those references. So to get the mass of the water, if you know the mass of your empty flask and your stopper, and you know the mass of the whole thing, then we can just take the mass of the whole thing and subtract off the mass of the flask and the stopper, and that will give you the mass of your water. So sorry, this should go in this blank. Oops, what did I just do? Okay. Oh, God. So we asked for the temperature in the lab. The temperature in the lab is approximately 23 degrees Celsius. Okay, that's not exact, but for the purposes of our lab, for what we're doing here, about 23 is a close enough approximation. And the density of water is approximately 1 gram per milliliter. So we're going to talk about in the next lab using the density of water a little more precisely. But for the purposes of our lab here, about 1 gram per milliliter is a close enough approximation. So the volume of the flask, do not write 50 milliliters in that blank. Okay, if I see 50 milliliters in that blank, I will take points off of your lab report, because that is not what you're trying to do. So we know the density of water, and we know the mass of our water, so what we're going to do is we're going to set up a unit conversion. So I'm going to add another slide in here, and we're going to talk about how to set this up. So you know the mass of your water from part C. Actually, this would be D. So you know the mass of your water, and you know the density of your water. So what you're going to do is you're going to take the mass of your water, however much water you have, and we know that the density of water is 1 gram per milliliter. And we know from doing unit conversions that if we have a unit we want to get rid of, it goes on the bottom of the next step. So if we have 1 gram of water is 1 milliliter of water. So essentially the mass of your water is also going to be the same as your volume, since it's so close to 1 gram per milliliter. So you're going to do this unit conversion here to get the mass, to get the volume of your water. Okay, so this is going to give you the volume of your water. Now the next thing asks for the mass of your unknown liquid. So if you recorded the mass of your unknown liquid with the empty flask and stopper, then we can again take the mass of our whole thing, okay, and let's get a different color pen for this. So we're going to take the mass of our empty flask plus our stopper plus our unknown liquid, and we're going to subtract the mass of our empty flask plus our stopper. So we're going to be taking C minus A, which is going to give us our unknown liquid, our mass of our unknown liquid. And then we know that density is equal to mass over volume. So for the density, what we're going to do is we're going to take the mass of our unknown liquid, which we just calculated in the previous blank, and we're going to divide that by the volume of the flask. Which we just determined. So if I continue my lettering here, we're essentially going to be taking H divided by G. And that's going to give you the density of your unknown liquid. So in part C, then you're going to determine the density of a solid. So what you're going to do is you're going to obtain an unknown metal. And I have two different types of unknown metals. I have a little silver bar, and then I have a bronze colored object that looks kind of like a thumbtack, except it has a thicker base and it has a star on the top. Either one of those is fine. You're just going to record which of your unknown metals you have, whether you have the silver bar or the brass or bronze with the star on top. So you already know the mass of your stopper flask from the previous section. So you're going to take the mass of your stopper flask and you're going to put your metal inside your flask, and you're going to weigh the stopper flask plus the metal. Then you're going to fill your flask to overflowing again, put your top on it with the metal in there, and you're going to dry it off. So you're going to get the mass of your metal and the mass of your water. So if I continue my lettering here, I have, let's see, I left off with I, so I have J, K, L, M, N, O, P, and Q. So if I know the mass of my stopper flask plus my metal and the mass of my stopper flask plus my metal plus my water, to get the mass of the metal, what I'm going to do is I'm going to take the value from K, which is my stopper flask plus my metal, and I'm going to subtract off the mass of the stopper flask, which I obtained in part A, or in the part that I labeled A, back in the density of a liquid. Then to get the mass of my water, I know the mass of my stopper flask plus my metal plus my water, and I know the mass of my stopper flask plus my metal. So I'm going to take my stopper flask plus my metal plus my water and subtract off the mass of the stopper flask plus the metal. Now, to get the volume of the water, do not just record 50 milliliters and do not record what you had in the last slide, because what you had in the last slide is no longer correct. So what you're going to do now is you're going to take your mass of water from part N here, whatever your mass of water is there, and you're going to do your unit conversion. So we know the density of water is 1 gram per milliliter. So that's what you're going to use to determine the volume of your water here. Then to get the volume of your metal, You know what the volume of the entire flask is because we determined that back in G on last slide. So you're going to take the volume of your entire flask and you're going to subtract the volume of water. So that's going to give you the volume of your metal. Then to calculate the density of your metal, what you're going to do is you're going to take the mass of your metal and you're going to divide it by the volume of your metal. And that will give you the density of your metal. So in the next section, in part D, we're going to use another method to determine the density of your metal. So what we're going to do this time is you're going to record the mass of your metal, which you already know because you determined that back in part C. Then you're going to get a graduated cylinder. And let me add another slide in here. And we're going to look at what a graduated cylinder, the graduated cylinder that you're using, looks like. So I'm going to kind of zoom in on a graduated cylinder here. So you're going to get a 50 milliliter graduated cylinder. Now I'm not going to draw the whole thing here because that would take too long. But let's just zoom in on a piece. So this is 20 milliliters and this is 30 milliliters. And then what you'll see on these graduate cylinders is a longer line that marks off the 5 and then smaller lines here that represent the ones place. So the way that we meet any piece of glassware in the lab is we record all of the places that we can see and we estimate one place beyond that. So let's take a look here. And let's say that our volume of water is about there. Okay, I'm not saying that's what your volume is going to be. I'm just giving an example here. So if I look at my graduated cylinder here, and you need to get down at eye level so that you can see the markings. So I can see the marking for 20, and then 21, 22. So I know that I have 22 milliliters. But remember I said that we record all the places we can see plus one place beyond that. So I can see that I have at least 22 milliliters here. Now I would say the meniscus, which is the bottom of this curve, is just slightly above that line. It's not quite right on that line. So I'm going to estimate that I have 22.1 milliliters. So when you record your volumes for your graduated cylinder, I'm going to be looking for those to have one decimal place in them. So make sure that you record your volumes from your graduated cylinder. So your volume from your graduated cylinder, you're going to record that with one decimal place. So let's say now that we drop our solid in, and for example, let's just say that our volume goes up to here. So if I look at this now, and again, this is just an example. So I'm at 25, 26, but I'm not quite up to 27. So I'm going to say 26 point, and let's see the bottom of this meniscus is kind of a little over halfway. So I'm going to estimate about 26.7 milliliters. Okay, so that's how you read your graduated cylinder. So you're going to record your initial and your final volume, and then you're going to subtract those two. You're going to take final minus initial to get the volume that the piece of metal took up. So then, to determine the density of your metal, you're again going to take the mass of your metal, divide it by the volume. Now, once you're done with that, you have 2 questions to answer at the bottom of your report sheet. The first one says, compare the 2 values for the density of your metal. Which one is more accurate and why? Now, let me be clear here. This question is not asking you which of the values was easier to do. Okay, I get a lot of students who will say the graduate cylinder just because they think that method was easier. It's not asking you which one is easier. It's asking you which one do you think gives you a more accurate value and why. And then the second question asks which one has more precision and why. So you'll need to review your definitions for precision and accuracy from chapter 1. So we talk about that in the lecture. So this is what your lab is going to be. You're going to determine the density of water, an unknown liquid, and your solid. So, make sure that you have read through the lab handout and you have completed your purpose and procedure for your lab and submitted that on Canvas, and also make sure that you've watched this video in its entirety and submitted the quiz. So, I will see you in lab.